Hello everyone, I'm Sally Sisu. Today I'm gonna present our work of VLGNet, Video Language Graph Matching Network for video grounding. First, let's look at the task. Video grounding is a fundamental yet challenging task. Let's take an example here. Given the query, the men then begin arm wrestling with one another while others are watching. We would like to locate the starting time and ending time for the activity as close as possible to the ground truth moment as shown in the pink box. The same applies to the second example here. Talking about the motivation for the design of VLGNet, we look at finer alignment between video and language at the token and snippet level so that our deep learning framework can learn the cross-modality interactions better and give better predictions. Interestingly, our VLGNet recasts this challenging into a graph matching problem. Specifically, we model language and video as graph, where tokens and snippets are nodes, and the token context and snippet context are modeled as edges. For intermodality modeling, we apply GCNext and syntactic GCN. For intermodality modeling, we design this graph matching layer for it. Here's an overview of VLGNet. Figure A is depicting the task. Given a query, we would like to find the query embed grounding as precise as possible. Instead of looking at the query moment and the query snippet level interactions, as shown in figure B and C, we actually look at the token snippet interactions. And here is the architecture for our VLGNet. The inputs are snippet features and the token embeddings, and the output should be the prediction of grounded moment in the video. For single modality representations, in our VLGNet, 1D convolutions and GCNext operations are applied on video snippets. Correspondingly, for tokens, they are fed into a stack of LSTM layers and syntactic GCN layers. Next, for cross-modality interactions, a novel graph matching layer is designed for cross-modal context modeling and multimodal fusion. Next, we apply this masked attention pooling layer to list all possible moment candidates and compute their features. Finally, a multi-layer perceptron computes each moment score to rank them as model predictions. Here's a bit more detail of the video language matching graph. We formulate video snippets and the language tokens as different nodes, and we also design three kinds of different features, different edges to model the interactions between among different modalities. Here are the experimental results for VLGNet on three commonly used datasets, ActivityNet, Dynamo, and Tacos. It is obvious to see that our VLGNet can achieve state-of-the-art results on three datasets under different evaluation metrics. Here is a bit more visualization for our VLGNet. Let's take a look at figure B. Given this query, our model can actually give very close prediction compared to the ground truth moment. An interesting finding is that our VLGNet's potential to give more reasonable prediction compared to the ground truth. In figure D, the camel riding behavior actually lasts for the whole video, so the ground truth is not that accurate. Instead, our VLGNet prediction matches with the facts. Then here's the end of the presentation of VLGNet. Here are all the authors for this great work. Thank you everyone for your attention.